In this video, we're going to introduce some important terms dealing with probability and statistics. Most of this stuff is going to be found in Chapter 3 of your textbook. First, we'll talk about two different types of statistics. The first type of statistics is called descriptive statistics, and this is used to summarize data. The second type of statistics is inferential statistics, and these types of statistics are used to draw conclusions about a population as a whole based on data taken from random samples. Things like graphs are examples of descriptive statistics. We'll see some inferential statistics a little bit later. Now we'll talk about types of data. The first type of data we'll talk about is qualitative data. And these are descriptions that can be observed but not measured, with numbers. Some examples might be things like color, texture, smell, taste. And a way that you can remember this is because the word quality is kind of in here. Next, we have quantitative data, and these are things that can be measured, and again, with numbers. And this kind of has the word quantity in it. Some examples of quantitative data would be things like height, age, exam scores, temperature, cost, debt, anything that can be measured with a number. Now we have a few important terms. A population is a precisely defined collection of values we want to study. An example of a population might be something like CUNY students, and this would involve every CUNY student. Oak trees, including every single particular oak tree, like bags of chips, or all bags of chips from a particular company, adults aged 18 to 29. Next term would be a sample. A sample is a part of a population. Usually we look at samples because often studying an entire population is impossible just because populations tend to be way too big. The next term we have is random sample. A random sample is a sample where every member of the population has an equal chance of being included. So a sample is just any part of the population. A random sample, every single member of the population has an equal chance of being included. A few more important terms and symbols we have. The letter N is used to denote the size of a sample. If we say something like N is equal to 5, that would mean there's 5 data points in our sample. This letter here, mu, it's a Greek lowercase letter m, is used to denote the mean of a population. X bar is the mean of a sample, which is just x with a bar over it. P, this should be lowercase p, the proportion or percent of a population that possesses a certain attribute. Then we have little p sub s, same thing but for a sample. Then we have this is sigma, this symbol, it's a lowercase Greek letter s, and that's the standard deviation of a population, and then sx is standard deviation of a sample. Now an important fact we have here, and this is part of inferential statistics, if we have a sample that is both random and your sample size is equal to 30 or it's larger than 30, we can say that the sample mean is a good approximation for the population mean. Sample proportion is a good approximation for the proportion of the population. Sample standard deviation is a good approximation for the population standard deviation. Just this symbol means approximate. Or you could also think of it as meaning a good estimate or very close to. If n is less than 30, other special conditions need to be met in order for these approximations to hold, and we'll talk more about that later. Now let's look at an example dealing with proportion. So let's say we have a random sample of 100 Pokemon was drawn from a population of Pokemon on the teacher's copy of Pokemon Gold and yielded 55 water-type Pokemon. Part A, find P sub s, the proportion of water-type Pokemon. We have 100 Pokemon in the sample, and 55 of them were water types, so this would just be 55 out of 100. And this is okay, you don't need to reduce this, you can leave this as is. If you want to reduce it, you can though. Part B, express P sub s as a percentage. The way we could do this is if we divide 55 by 100, we would end up getting 0.55, so that's if we wanted to do it as a decimal. If we take 0.55 and multiply it by 100%, we end up getting 55%. Now let's look at another example. A random sample of n equals 5 was drawn from a population of adults living in New York and yielding the following ages: 52, 24, 17, 63, and 35. Find x bar, the average age. So to find the average here, we would add up all of the values in our sample and divide by the number of values we have. The way that we would write this out as a math formula would be like this. Now I know that this looks horrendous, but I'm going to explain what all of this means. This means add up every term in the sample, and this n here means we need to divide by the size of the sample. Oh, and by the way, this here is an uppercase sigma or Greek letter S, not to be confused with lowercase sigma. Okay, so now we'll get to finding our average. So here x bar is going to be equal to 52 plus 24 plus 17 plus 63 plus 35, and then we have 1, 2, 3, 4, 5. So we're going to divide that by 5. X bar is equal to 191 over 5, which works out to be 38.2, and that would be our average age.